Good afternoon, teachers. Good afternoon, grade 12 learners. My name is Mohapi. I'm going to take you through some few exercises on Euclidean geometry to try and prepare thoroughly for this topic. Remember, this is the topic that takes about 50 marks in paper 2. And remember, paper 2 will be written on the 3rd of November. On the 3rd of November, grade 12 learners will be sitting for the final examination on paper 2, mathematics paper 2. Thank you. Without any waste of time, let me take you through some few exercises just to make sure that I refresh your mind on the application of all the geometric theorems. We've done lots and lots of theorems. I think now what we need to do is just to put them into practice, because I believe once you practice them all, then everything will become easy, and you as learners will also be familiar with the theorems. Let me take you through the first exercise. Thank you. If you can check in there, we've got the question. Let's analyze the question. From my previous presentations, I've always been emphasizing the importance of analyzing the given statement. Once you analyze the given statement, whatever information that you pick up, you immediately indicate that information on the diagram. That is the accompanying diagram. Thank you. Let's go. In the diagram alongside, AB is a chord. You look for AB. Here is AB. AB is a chord of a circle with center O, meaning that O is the center of the circle. ON is perpendicular to AB. Look at ON. ON perpendicular to AB at M. I think we can all see that, and that angle is already marked 90 degrees. MN is 30 millimeters. We go to MN. Check MN. This MN is 30 millimeters. Immediately, you mark it on the diagram to know that MN is 30 millimeters. And the radius of the circle is 150 millimeters. What is the radius? A line from the center to the circumference. Here is the radius. OA is the radius. OB is also the radius. ON is also the radius. So radius is 150 millimeters. This radius is 150 millimeters. All the information that you have, you immediately mark it on the diagram. The question states, calculate with reasons the length of AB. The length of AB. Thank you. Let's analyze. Remember what is given. Radius is 150 millimeters. Check. OA is 150. ON is 150. Look at ON. ON is equals to 150 millimeters because ON is the radius. But if we can check, ON is divided into two. ON is divided into OM plus MN. They must give us 150. Check. OM plus MN, they should give us 150. So we can work out the length of OM. Therefore, it means OM plus MN, check MN, is given as 30 millimeters, which is equal to 150 millimeters. Therefore, OM will then be equal to 150 minus 30, which will give us 120 millimeters. That is the length of OM. So we come here, this one is 100 OM. What is OM? OM is 120 millimeters. That's OM. So let's go through the questions. The question is, we've calculated with reasons the length of AB. The length of AB. Now that we've got OM as 120, it's easy for us to calculate AM. According to Pythagoras' theorem, OA squared is equals to OA squared is equals to OM squared plus MAM squared. This is according to Pythagoras' theorem. Pythagoras' theorem. Now let's substitute. OA, look at OO, it's 150. You square it. OM is 120. You square it. AM is our unknown. We want to determine the length of AM. So let's square 150 with the aid of a calculator. Work it out. 150, you square it. I think 150 squared will give you 22,500. 22,500, which is equal to 120. Let's check 120. What is, when you square it, what will be the value? 120, when you square it, you've got 14,400. This one gives us 14,400 plus AM squared. Now it becomes easy for us to determine the length of AM squared. We group the like terms. You transpose 14,400, you transpose to the left. Then you've got 22,500 minus 14,400. Let's subtract 22,500 minus 14,400. Let's check the difference, 8,100. The difference here is 8,100. Now we can determine the length of AM by determining the square root on both sides. Therefore, AM, you determine the positive root of 81, even the positive root of AM squared. Therefore, AM will then be equal to square root 81,000, 8,100, which gives you 90. Therefore, it means AM. Let's go back to the diagram. AM is equal to 90 millimeters. That is the length of AM. Therefore, let me write it nicely. AM is equals to 90 millimeters. Let's check the diagram. We've got AM. This AM is equals to 90 millimeters. The question wants us to calculate the length of AB. Check AB. But we know from one of the theorems that we did that AM is equal to MB. Let's write it down. But AM is equals to MB. It's a geometry. We must provide a reason for that statement. Why do we say AM is equals to MB? The reason is, remember, the perpendicular drawn from the center to the chord bisect the chord. Perpendicular drawn from the center to the chord bisect the chord. And the word bisect means to cut into two equal parts. Therefore, we've got perpendicular drawn from center to chord. The perpendicular drawn from center to chord bisect the chord. What does that mean? It therefore means MB is also equals to 90 millimeters. Here, let me go to the diagram. I mark it. Remember, AM is equals to MB. This side is equals to that one. If AM is 90 millimeters, it means MB is also equals to 90 millimeters. Therefore, it's easy for us to answer the question. What will be the length of AB? 90 plus 90, which will give us 180 millimeters. Therefore, you conclude by saying, therefore, AB is equals to 180 millimeters. When you add the two, 90 millimeters. Thank you. It was just a brain teaser. It was just a brain teaser to say, let's start first by working on this one. And my approach today, mainly, is not going to solve the problems for you. For you to understand the solution to a problem, firstly, you need to attempt it on your own. Try to identify where you've got problems. And then thereafter, I'll come up with the explanation, the solution. Then you can check your work out against mine. Because sometimes it does not help to every time come up with a problem and solve it for you. Learners must be able to solve, and for them to realize their weaknesses is for them to work out the solutions. So I'm going to give you a solution, a problem to do on your own, and then after 5 minutes, I will then present the solution. But firstly, I want you to try this one on your own. Check 7.2. I hope it's clear from the screens. 7.2. Then 7.2, the question states, I think it's clear. In the diagram alongside, PR is a chord of the circle with center M and radius R. Remember what I said earlier, you immediately indicate the given information on the diagram. So in the diagram alongside, PR is a chord of the circle with center M, meaning that M is the center. Here is M. M is the center. PR is a chord. PR is a chord very much similar to the problem that we just did. The perpendicular from center M intersects PR at N. Therefore, here's the perpendicular from M is the center. The perpendicular 90 degrees here from center M intersects PR at N. Here it is clearly indicated. PR is 120 units. PR 120, remember what I said earlier, indicate the given information on the diagram. PR is 120 units. QN is 20 units. MN is X units. The first question, write R in terms of X, is for a mark. The second question, calculate the value of R for 5 marks. I want you, grade 12 learners, to do this problem, to solve this one for me in 5 minutes time. After 5 minutes, I will then present the solution to you. But you will then check your work against mine. For now, attempt it, do it on your own. Thank you. I'll carry on the solution in 5 minutes time. Welcome. I hope you got it right. Check your work against mine. Remember the first thing that I said? Indicate the given information on the diagram. In the diagram alongside, PR is a chord of the circle with center M and radius R. R represent the radius, M is the center. PR is 120 units. Check PR. PR, the whole of PR, from here, the whole of PR, 120 units. What does that mean? It therefore means if PR is 120, it means PN will be 60 and NR will then be 60. Why? The perpendicular drawn from the center of the chord bisect the chord. What I said is that PN is equals to NR. Why? The reason, perpendicular drawn from center to chord. Perpendicular drawn from center to chord bisect the chord. Therefore, what does that mean? It means PN is equals to 60 units. PN is 60, NR is 60. We're just indicating the given information on the diagram. QN is 20. What is QN? Check QN. QN, this distance here, is 20 units. And then MN is X. MN is X. Thank you. The first question, 7.2.1. Let's answer that. For 1 mark, write R in terms of X. Write R in terms of X. Check. What does R represent? The radius. And by definition, the radius is the line from the center of the circle to the circumference. So if you can check, MP is the radius. MQ is also the radius, meaning that R will then be equals to X plus 20. Why? MP is equals to MQ, and they are both radii. MP is R, MQ is X plus 20. So if you write R in terms of X, R is equals to X plus 20. The reason is because MP is equals to MQ, and they are both the radii. Thank you. The first question answered. We have expressed R in terms of X. Let's look at 7.2.2. Calculate the value of R. Calculate the value of R. What it means that for us to determine the value of R, we must first determine X. Because once we have the value of X, remember, R is equals to X plus 20. So once we get the value of R, once we get the value of X, it becomes easy for us to determine the length of R, the length of the radius. Let's check from the two diagrams. Let's apply the Pythagoras theorem. Check. MN. In this triangle, in triangle MNP. In that triangle MNP. In triangle MNP. Check what is happening in that triangle. R squared is equals to 60 squared plus X squared. It's a geometry, therefore we must provide a reason for every statement. The reason here is Pythagoras theorem. This is the application of Pythagoras theorem. Let's solve it. Remember R from 7.2.1, R is equals to X plus 20. We substitute, here we've got R, we substitute by X plus 20. Then you square it, which is equals to 60 squared plus X squared. Now let's apply algebra to solve this one. If you expand here, you've got X squared. Multiply here, you've got 40X. You square 20, then it will give you 400. Check 60. You square 60. 60 squared will then give you 3,600. 3,600 plus X squared. Now let's group the like terms. X squared, you transpose to the other side, cancels off. X squared eliminates X squared. So X squared is off. What are we left with? On the right hand side, we'll then be left with 40X. Now we need to transpose 400 to the right. Then you've got 3,600 minus 400, which will give you 3,200. Now, what do we do for us to solve X? You divide by 40. If you divide by 40 both sides, you've got 40 will then be equals to, let me check, minus 400. Divide by 40. Thank you. It means you've got 3,200. You divide by 40, therefore X will be equals to 80 units. X will then be equals to 80 units. Let us not forget the question. The question states, calculate the value of R. Calculate the value of R. Calculate the value of R. Now we have got X. X is equals to 80 units. Remember from 7.2.1, R is equals to X plus 20. Remember, but R is equals to X plus 20. This is what we have proved in 1. Proved in 7.2.1. Therefore, we substitute R will then be equals to, you substitute X by 80. You've got 80 units plus 20 units. Therefore, R is equals to 100 units. R is equals to 100 units. I hope you enjoyed it. I did 2 geometric radius, mainly focusing on the application of the Pythagoras theorem, together with the theorem that states the line joining the center of the circle to the midpoint of a chord is perpendicular to the chord, as well as its converse, the perpendicular from the chord, the perpendicular drawn from the center to the chord, bisect the chord. So those are the 2 problems that we have done thus far, and I hope you have learned something, and I hope that even this one, you were able to solve it on your own. Now we carry on with practice of all these other theorems there. Let's carry on. There we are. Look at that problem. Look at the problem. Thank you. 7.2. 7.2, this one. In the diagram alongside, O is the center of the circle ABDC. O is the center of the circle ABDC. What does that mean? It means point A, point B, point D, point C lie on the circumference of the circle. Then we say they are concyclic. They lie on the circumference of the circle, meaning that they are concyclic. O is joined to B and C. O is the center. Now you join O to B and O to C. Therefore, you've got OB as the radius, OC as the radius. And you know the radii of the same circle are equal in length. Angle OBX. Check OBX. It's clearly marked on the diagram. OBX. OBC, I'm sorry. Angle OBC is equals to X. Angle OBC is equals to the X. Sorry for that. The first question, determine with reasons the following angles in terms of X. The first one, you determine O1 in terms of X. Second one, determine angle A in terms of X. Last one, 7.2.3, you determine angle D in terms of X. 2, 4, 6 marks. I think this 6 marks, you can finish it off in 4 minutes time. I'm going to give you 4 minutes to try this one on your own. Remember the key, indicate the given information in the diagram, and then you apply your theorems. Good luck. I'll continue with the solution to this problem after 4 minutes. Carry on now. Welcome, welcome. Check your work against mine. Check your work against mine. Thank you. In the diagram alongside, O is the center of the circle ABDC. O is joined to B and C. O is joined to B and C. What does that mean? It means OB is equals to OC because those are the radii of the same circle. Angle OBC is equals to X. It's marked X. This angle here is marked X. So the first question, determine with reasons the following angles in terms of X. Let's start with O1. Here is O1. 7.2.1. Statement number 1. Angle C1 is also equals to X. Why do I say angle C1 is equals to this X? Why do I say this angle C1 is equals to X? The reason is that OB is equals to OC, and those are the radii of the same circle. What does that mean? It means this angle here is also X. So it becomes easy for us to determine O1 in terms of X, because this angle, O1, plus X, plus C1, they all give us 180 degrees. Those are the angles of a triangle. We know angles of a triangle add up to 180 degrees. Interior angles of a triangle. Angles of a triangle. Interior angles of a triangle, they add up to 180. Therefore, we've got O1 plus X. Remember, C1 is also equals to X is equals to 180 degrees. Then you make O1. We make O1 the subject of the formula. Angle O1 will then be equals to 180 degrees minus X plus X gives 2x, and then transpose to the right, then it goes minus 2x. Then that will be the size of angle O1. 7.2.1. 7.2.1. 01 will then be equal to 180 degrees minus 2x, because the question states determine with reasons the following angles in terms of x. So 01 in terms of x will then be equals to 180 degrees minus 2x. I hope you enjoyed that one. Second one, let's determine angle A in terms of x. Numbering is key. 7.2.2. We want to determine angle A in terms of x. Remember, from the given statement, O is the center of the circle. So if O is the center of the circle, we then say O1 is equals to twice angle A. Remember, there is a theorem that states the angle which an arc of a circle subtends at center is twice the angle it subtends on the circumference of the circle. So you write down the reason. Angle at center is equal to 2 times angle at the circumference of the circle. Angle at center is equal to twice angle at the circumference of the circle. Check O1. Remember, angle O1, we are from 7.2.1. O1 is equal to 180 degrees minus 2x. Now we substitute it here. We substitute O1 by 180 degrees minus 2x, which will then give you 2 times angle A. So to determine angle A, you divide by 2 both sides. Let's divide by 2. If you divide by 2 here, you've got angle A here. You divide by 2 here, it's 90 degrees. You divide by 2 there, it's x. Now we're done. We've got the value of angle A in terms of x. Therefore, in terms of x, angle A is equal to 90 degrees minus x. That was 7.2.2. I hope you also got it right. I hope you also got it right. Thank you. Let's check the last one. 7.2.3. 7.2.3, angle D. Determine with reasons the size of angle D in terms of x. Where is angle D? Here it is. Thank you. Let's answer 7.2.3 and see how it goes. 7.2.3. If you look at the diagram, check angle A, check angle D. How do they relate? Because A, B, D, C are points on the circumference of the circle. Therefore, it means A, B, D, C is a cyclic quad. It's a cyclic quad. As a result, angle A plus angle D must give you 180 degrees. Those are the opposite angles of a cyclic quad. There is a theorem relating to cyclic quad which states opposite angles of a cyclic quad are supplementary. That's why we say angle A plus angle D is equal to 180 degrees. Those are the opposite angles of a cyclic quad. We said angle A plus angle D gives us 180 degrees. These are the opposite angles of cyclic quad. Those are the opposite angles of cyclic quad. Opposite angle of cyclic quadrilateral. Angle A from 7.2.2, angle A is equal to 90 degrees minus x. So we substitute angle A here by 90 degrees minus x plus angle D. They will give us 180 degrees. Now it's easy for us to determine the magnitude or the size of angle D. Transpose 90 to the right. 180 degrees minus 90 will give you 90 degrees. This is x. You transpose it to the right. It becomes positive x. Therefore, it means angle D will then be equal to 90 degrees plus x. I hope you enjoyed this one. I hope you got it right. Remember, the objectives for today's lesson is to revise Euclidean geometry. All those riders, come up with solution to the riders, because we believe practice makes perfect. If you do lots and lots of exercises relating to the solution of solving geometric riders, then even in the exam, they will become easy. Thank you very much. I think should give you we should do one more exercise before we go for a break. One more exercise before we go for a break. Check this one, the last one. It's question 8. I hope it's clear on your screens. In the diagram, ST parallel to QW, and PQR is a tangent to the circle. pick you up.